CBT Nuggets JNCIA series, Class of Service. Well, in this nugget, we've got a wide variety of topics to look at, some advanced information on controlling our routing domains. And we're going to start out looking at a topic that probably should have been covered officially in the firewall filters nugget, but I kind of got time constrained. So I'm going to start out here looking at policing or rate limiting. Then we will define officially what class of service is and what we use it for. We'll look at the two main deployment methods of class of service. Then we'll start looking at things like forwarding classes, multi-field classifiers, behavior aggregates, policers, traffic scheduling, and then we'll finish up looking at a case study, something we can use when we deploy class of service in our Nugget Lab environment in our new job. Sound good? Okay, let's dive in. Okay, in the previous nugget on firewall filters, we learned that we can drop packets or we can accept packets using firewall filters. But we also know that we can count packets. We saw that in one of our configuration examples. But we can go even further than that and do something that really kind of falls under the umbrella of quality of service in the sense that we can police or rate limit traffic. Now, as you can see from our diagram here, we have packets that are coming ingress or inbound to a router. Now, this could be coming inbound, let's say, to our headquarters router from a particular branch office or vice versa. What we want to do is we want to apply a policing policy or rate limiting so that we're only going to allow a certain number of bits per second, a certain number of K bits per second, 1,000 bits, or maybe million, 100 million bits, or even into the G or gigabit or billion. So we can control the amount of traffic that comes in, and if we exceed that particular rate, we will drop packets by sending them over here to the bit bucket or where the bits go to die. And so we're controlling the amount of packet flow through our particular device, and we use our firewall filter mechanism that we've already learned to do that. And we use our normal match conditions. We can use addresses. We can say based on certain protocols, certain ports, we're going to figure out which traffic on an interface will be subject to rate limiting. Keep in mind, though, that we can go even further with this with our Junos OS. And we'll learn more about this in the future. But we can implement interface-based policers that we can apply directly to a certain protocol family, like, for example, VPN traffic or IPv6 or MPLS traffic, just for this policing or rate limiting without having to use other firewall filtering. In other words, we're not going to block the traffic from that protocol. We just want to rate limit it, regardless of where it comes from or where it's going to. Also, keep in mind that the support for policing is going to vary along your platform. You know, I'm using the J series routers here, but on the higher end routers, we can have different support for different protocols, addresses and ports, and so on. Now, I have this simple little diagram here of sending packets to the bit bucket, and what this icon really represents here is the bit bucket algorithm. Great name for a band. And we can configure two rate limits for our traffic. Okay, here's our traffic going through. We can determine the bandwidth, which is the number of bits per second, the number of K bits, 1,000, M, million, or G, billion bits per second. And we could say, what is the maximum burst size? And usually we allow a burst size up to a certain amount, maybe like 1.5, 1.3 to 1.5 times the bandwidth. The difference is we measure bandwidth in bits, we measure burst size in bytes. And that's important to keep in mind when we're configuring our policy. So let's just go ahead and jump onto my 2320 and we'll do a basic configuration of a policy that we're ultimately going to apply this way. Let's say that this is a branch office, okay? And this is our headquarters up here. What we really want to do is we want to apply this policer on an inbound direction. We want to have a bandwidth limit inbound on this interface going to the headquarters of 500K, 500,000 bits per second. But we're going to allow it to burst to 100K bytes per second. So let's go ahead and go over and configure this that we're ultimately going to apply to this interface gig E003 unit 0. As you can see, I have a commit confirmed to roll back in 20 minutes because I don't really want to apply this configuration. I just want to practice on this router. And so in 20 minutes, if I don't commit it, it will automatically roll it back. And that's a great way to go when you're doing configurations on your routers and you just want to work with different policies. You want to experiment with different syntax. So make sure that you get into the Edit Firewall configuration hierarchy, which is where I'm at right now. And I'm going to set my policer. Okay, and if I hit a question mark here, I can see that all it really wants to do is give it a name, right? So let's call this my cop, all right? Because this is a policer, right? And by the way, policing and rate limiting is synonymous, and you hear those terms used interchangeably. So we're going to create a policer called my cop, and we're going to say, by the way, what are our options? Well, we can say if it's exceeding, which is what we're shooting for here, okay? If it's exceeding, then we're going to do something, right? So let's just start out with that command. If exceeding, remember our bandwidth? We have some options here. We can say if it exceeds a bandwidth limit, I mentioned that, or I could even say if it exceeds a certain percentage of the available bandwidth. That's an option too, maybe for a service provider to limit customers. We're going to go ahead and go with the hard bandwidth limit of 500K bits per second. And then you can see here it's in bits per second. And then we're also going to do an entry in this policy for a burst size. And the burst size is going to be anywhere from 1,500 up to a ton of different, but it's in bytes, okay? So keep that in mind. So we're going to say if exceeding bandwidth limit, not bandwidth percent, 500K with a burst size limit of 100K bytes. And then we'll go up and we'll go back here. I'm just moving back because we have one more command to issue here in our policer called mycop. We're going to say, all right, then what are we going to do? We're going to discard. So if we exceed 500,000 bits per second or we burst up beyond 100 bytes per second, we're going to discard those packets to the bit bucket. Okay, there we go. Now all we've done so far is we've created our policer, but we have to actually use a firewall filter, right, to actually apply this. So we're going to set from the family INET a filter, and we'll call this rate limit. Or how about rate LMT, all caps, so I know I created it. Our first term is going to be called, we're going to match a net for policing. Okay, how's that? We're going to match a network for my cop. And it's from the source address. And if we go back to our diagram, it was actually that interface going up to the cloud. So 172.18.1.0/30. Okay, we're not done yet though, because we have to say, all right, if we match that particular network, what are we going to do? Well, then we're going to apply the policer mycop, right? Now that's the first term my firewall filter. Okay, so if it's from that network with a source address of that net, we're going to police the traffic at 500K bits per second with a burst up to 100K bytes per second. But what if it's not from that network? Okay, we only want to rate limit that particular network, the branch office. So in that case, we'll create another term. So let's go up here and create another term, and we'll call that one the else except term. I want to use a dash in there. Else except, then we'll accept it. So if it's from any other network, we'll go ahead and accept the traffic. We won't apply any policing to it. So now we can do a show command, and we can see here, here's our filter, rate limit, and we've got our first term, which is matching the network of policing from source address 1.0/30. If it's from that network, we'll apply the policer mycop, which is, by the way, defined down here. If it's not, if it's an exception to that network, we'll go ahead and accept the traffic. Here's the policer mycop with the if exceeding command, and then we've got our bandwidth limit 500K. We could also use M or G, okay, depending upon the size of your network and the bandwidth of your network, but 500K bits per second, bursting up to 100K bytes per second. If that's the case, then the action we're going to take is the discard. Now, one thing I want you to be able to do, by the way, and this is a good exercise, and you can get your hands on configurations from Juniper at their website, But it's a good idea to be able to come in and look at a configuration, because a lot of the stuff you're going to see is actually, they're going to show you the results of the configuration. So here's what I'm getting at. If you saw this result of this show command, okay, and you know you had to create your policer first, would you be able to go in based on this configuration and replicate this? Okay, would you know from looking at this that we're in the edit firewall hierarchy? So you could go in there and you would say then policer followed by the name, and then you can just do a question mark to see what commands you can issue. One of the commands will be if exceeding, so put in there if exceeding, and then you've got a couple of options: bandwidth limit, bandwidth percentage, right? And then you can optionally put in a burst size. You don't have to put in a burst size, but it's usually pretty good, especially if you're dealing with bursty type traffic, okay? So could you go in and look at the configuration that Juniper gives you and then replicate this using your set commands in the right firewall mode? Very important skill to acquire, and that it also it helps you in being able to evaluate what you're seeing here in this configuration, which will be important on the JNCIA exam. There won't be any configuration. There's no simulation questions. What the bulk of your configuration questions will be is you're looking at an existing firewall filter or an existing policer and just looking at the configuration and answering a multiple choice question based on the configuration. So the best way to be able to answer the multiple choice question is to be able to take this configuration and use your own set commands. You know, set policer mycop if exceeding, set family inet filter, and to do that yourself in your own environment. Even if you have to sit down and just get out a word processor and just kind of write down the syntax commands to actually implement this configuration. It's going to be a great exercise for you. Now let me just break it down for you what class of service does for you. It allows you to take the packets that, for example, are coming inbound to your Juniper router and classify them as a certain type of traffic, like data traffic or voice traffic or video traffic. And then with that, we can use different types of handlers. Now, before we can have different handling of different classes of traffic, we have to kind of analyze how the router is going to normally handle traffic. Here's what it does, and I have it down here, RED. Your router is going to use, by default, a random early detection RED algorithm. And it will do this to avoid congestion. The algorithm will drop random packets selectively before congestion gets to a particular critical rate. And this can cause TCP sessions to go into what we call a slow start mode. And higher bandwidth data streams like voice and video are going to be negatively affected by this default RED algorithm. It also is going to handle traffic in a first come first serve best effort queue. So it's a first come first serve. What we're going to do here with class of service, or COS, is we're going to put our traffic into what are called forwarding classes. That's the first thing we're going to do. We're going to differentiate it on a class by class basis. So then, based on the membership of that class, we can then differentiate the traffic one from another. We can use certain components in Junos to treat traffic differently in a unique way depending upon its forwarding class membership. And then we'll also use tools that we can mark and categorize that traffic. Why would we mark it? So that other devices in our topology know how to handle that traffic. So usually, if you're going to do this type of thing, including differentiating traffic, you probably want to do it across all of your routers in your domain or in your routing group. And again, the goal here is to prioritize latency sensitive traffic like voice over IP or multimedia. Now, let me tell you something that the class of service feature will not do. Okay, so we'll put the universal not symbol. Okay, what will it not do? It doesn't make your network faster, it doesn't add more bandwidth, and it doesn't reduce congestion. We have to use other mechanisms to do that. What we're doing is we're basically controlling how our existing congestion based on the random early detection algorithm affects different types of traffic, right? So we'd like to have our existing bandwidth and existing configuration improve the performance of voice traffic or multimedia traffic by prioritizing it over normal data traffic. Hopefully that makes sense. We're going to allocate our existing bandwidth for different types of traffic. Something else we'll also use this for, let's say if we're a service provider, is that we will control our congestion to be able to match up to our service level agreements that either we have with our service provider or with other customers of our enterprise network. So this is all made possible, as I mentioned, by using a construct which is really just kind of a logical container known as a forwarding class. Okay, so we're going to classify our traffic. We have 3 packets here. We have packet X, packet Y, and packet Z. We will take this type of traffic, packet X, and then put it in the voice class. Packet Y over here is video traffic, so we'll put it in the video class. And then packet Z here represents data traffic, so we'll put that in the data class. So we're going to identify traffic that should get common treatment, okay? In other words, it's part of the best effort queue, and then other types of traffic that should get preferential treatment, okay? So during the output, as we're coming from the Junos here, we're going to associate traffic with a forwarding class during the classification process. The system will assign traffic to a particular output queue based on the forwarding class membership, and then it rewrites markers, okay? And these are called behavior aggregate markers. Now, a lot of people in Juniper, they will make a traffic class synonymous with an output queue. And early on you may want to go ahead and do that because there's a one-to-one mapping of a forwarding class to an output queue. So for example, we can see that the forwarding class of voice for X will be in this output queue. The forwarding class for Y traffic, which is video traffic, is in this output queue, and the forwarding class for Z traffic, which is data traffic, is in this output queue. But that strict of a synonymous definition as we move forward isn't going to hold up because a lot of our platforms, the higher end platforms especially, they're going to support more forwarding classes than they do queues. So things can get confusing. Let's talk about another concept here called loss priority. You can take a packet like, let's say, the Y packet, which is video, and we can assign a priority and tell the system that it should, when it's dropping packets, maybe give this a higher priority so this won't be the first category of packet that gets dropped by the RED algorithm. Now, that's an advanced technique, but I just want you to know that you can do that kind of thing and get very granular and very specific with your class of service. Okay, the class of service processor on this Junos router is going to do a couple of things. It can set the forwarding class as well as the loss priority for a particular packet, either ingress or egress, on a particular interface. And I mentioned loss priority a while ago, remember? It basically is the process that tells the system what priority it should apply to the packet dropping nature during congestion based on RED. Now you can configure your devices to set the forwarding class and the loss priority for a particular packet based on a number of values in the header fields. You can base it on DSCP values or diffserved code point values, IP precedence value in the IP precedence field of the IP header, MPLS information, and so on and so forth. Now typically this is, let's say this is an edge device for our organization, right? An edge device that connects up to a service provider. Typically the edge devices are going to set these fields, and that's going to basically be an indicator of the category of traffic we're dealing with. And because of this, the core devices or the other interior LAN devices, routers for example, won't have to do recategorization on the traffic it receives coming in from this router. And since these fields indicate the category of traffic that this packet belongs to, for example, this type of classification is referred to as BA, or behavior aggregate. We can also configure our Junos router to set the forwarding class and the lost priority values on both ingress and egress traffic. And we implement what are called multi-field classifiers using firewall filters. What's a multi-field classifier, you ask? Well, it allows us to choose packets using all of the selection criteria of a firewall filter. Remember, like a Cisco Extended Access Control List. It also allows you to set the forwarding class and the loss priority with a then clause, right? If it matches something, then assign it to a certain forwarding class X, for example, or apply a certain loss priority value to it. So, just like we looked at the policer that worked with firewall filters, our class of service multi-field classifiers can also work with firewall filters. Now, my header up here says class of service deployment methods. Well, let's go ahead and talk about those. Now, our two primary deployment methods are based on two criteria. First of all, is our class of service going to be providing differentiated forwarding services like we see here on a single device? Or is it going to be applied to multiple devices within our network, like we see down here? So, building on our earlier information, if we're deploying it on a single device, let's say the branch device at our regional branch office, then typically our Junos router will classify packets as they pass through using a multi-field classifier. Then it'll take the classification and offer our particular service levels and forward the packets without any behavior aggregate markings. In other words, it's not going to use markings like DSCP, IP precedence, and things like that, and then send them on into the network. But if you have multiple devices like we see down here, we use class of service to provide differentiated services, and you will usually perform that classification on the edge device, let's say right here, and then propagate that classification through our network using BA, the behavior aggregate. So the edge device will classify our traffic using a multi-field classifier as it comes ingress into the network, and as it transmits packets into the network to other routers, it marks the packets with a BA, a behavior aggregate. So the other devices in the network will read that BA and then automatically set the right forwarding class and loss priority without having to use the multi-field classifier or have to be configured on these routers. That's a big advantage. Okay, so we use BAs in network-wide class of service applications to make sure we have consistent class of service functionality throughout our network. Also, it makes it simpler to create and maintain accurate multi-field classifiers on each system. Without the behavior aggregate, every device would have to have a multi-field classifier that's capable of classifying all the traffic that comes into the network. And if you made a classification change on the edge device, for example, you'd have to make that change on all of the other routers. And another advantage is, I haven't mentioned this yet, is if you go ahead and if you're using Ethernet, you can set 802.1p bits, which is basically IEEE layer 2 quality of service, class of service. Using the behavior aggregate, we can set these bits on our Ethernet, and this will allow for class of service aware Juniper switches, for example like the one I'm using, to also provide differentiated services to the frames that are coming through those devices. That's an awesome advantage. Okay, remember back to that topology, right? We have the traffic coming into that edge router from the 172.16.1.0/30 network. Now with the multi-field classifier, we're just applying this on that single edge router. So as the packet comes in, it's going to be without the behavior aggregate. And as it's sent into my network, right, it's going to also be without the behavior aggregate. So we're going to apply the multi-field classifier with the firewall filter on this router. As a matter of fact, it'll be on this interface right here, and this is our configuration on that interface. Let's go ahead and look at the filter first. So I've got a filter that I've created called myCOS. So in myCOS, the first term says from the source address of 172.16.1.0/30, which is of course where we're coming from here. If that's the case, then the action we're going to take is we're going to apply it to the forwarding class for expedited forwarding. And we're going to accept that traffic. My next term is called others. Okay, other traffic will be, the action will be to accept it. So we're going to be at this point accepting all traffic inbound on this GigE003 interface. But if it's from this address, we're going to apply to the expedited forwarding class. In other words, we're going to put it in the low latency queue, not the default queue. Now over here you can see how I'm applying it. I'm going to the hierarchy of edit interfaces GigE003 unit 0, and I'm going to say, look, show me what's up. Okay, it's in family iNet. I'm applying a filter which is input or inbound, the input filter known as myCOS. Of course, there it is right there. And you can see the address on that particular interface is 1.2, so I'm applying that filter to this interface, which has an IP address of 172.18.1.2/30. Let's go ahead and configure this on my router. So we'll say it's going to be edit firewall, we'll say family iNet. Let's get down into that hierarchy. And we want to set a filter which is myCOS, remember? And the first term, we called it admin, and we're saying from source address of 172.16.1.0/30. So that's our if statement, right? So we'll go up here and say, if that's the case, then we want to apply it to the forwarding class of expedited forwarding. We've got some default forwarding classes here, and that's one of them. If I go back here, by the way, do a question mark, you can see the best effort is the default. Okay, so we're just basically saying let's put it in the expedited forwarding class. And then the next thing I want to do is this, add another then accept it. We have to put the accept in there because that's the terminating action, remember? That way, if this is applied, it will not go to my next term. So my next term, or the second term, we'll call others, right? That was the term I used in the example. Then we'll accept it. So we'll accept the traffic that's not from that network, but we won't put it in the expedited forwarding class. And then we can do the show command. And of course, here's the results that we saw. And this is, going back to what I just showed you. This is the results of the configuration. And then, of course, you would want to go to the top and then edit interfaces, set GigE003.0 family iNet, and we're going to apply the filter myCOS. Oops, filter, don't forget, input on the interface, myCOS, and do a show command. And let's see here. There we go. GigE003. Here's our address. We've got a filter applied of the family iNet. Its input, it's the myCOS multi-field classifier class of service filter, done with a traditional firewall filter. Awesome. Let's talk next about behavior aggregates. As the packet comes to our edge router here, there's no BA on it. But we're going to apply a behavior aggregate to output or egress on this interface as we're sending these packets into our internal routers or our backbone core routers. So what we're doing is we're going to configure this Junos router to apply a BA marker to packets that are leaving this gigabit 001 interface. Remember over here we were on gigabit 003. This will be the 001 interface. And we do this by applying what's called a rewrite rule. And we only have to set this rewrite rule one time as we send this packet into the core of our network. Now this is for layer 3 stuff, okay, like IP precedence and DSCP values. Keep that in mind. So let's basically go to this particular interface right here on my 2320 and apply a read-write rule in the class of service area. What we're going to do is we're going to apply the default IP precedence markings to this packet that is going outbound on this interface. Now, of course, I could do a whole lot more to it, but at this point, we really want to keep it simple. You'll get much deeper into this as you progress farther on in your Juniper training. Now realize, I can't apply both IP precedence and DSCP rules. And the reason why we can't set both of those is because they use the same bits in the IP layer 3 header, okay? What we're doing with this behavior aggregate is we're basically setting it back to the default INET precedence. Eventually, when this gets to another router that is leaving our network, we'll have to apply a behavior aggregate classifier on the traffic going into that router so that we can send it out with no BA markings on it. In other words, we send it to an extranet partner or to another customer or another department or the data center, whatever. But let's focus on this 2320 router right here. We want to edit the class of service area here. And in that hierarchy, we're going to set on our interface, and we said it's, for me, it's gig E00. Remember, 003 was the input interface that didn't have any BA markings on it. This is going to be a behavior aggregate, so I'm going to add a BA marking to this interface going into my network, unit 0. Check this out. We can apply a bunch of stuff. I mean, this is all what we would call behavior aggregates here. But we're going to apply this rewrite rule. Okay? So we want to rewrite the rule applied to outgoing packets. So we'll just put a rewrite rule there. Then we've got some options, a lot of options. See, we can rewrite and we can modify DSCP. We can modify MPLS EXP rules. We can modify INET precedence. Let's go ahead and do that. Let's go ahead and do INET precedence and say we're going to set it back to the default values. Hit enter, and there we go. That's all we have to do. So this is what we call a BA rewrite. What are we doing? Well, we're using a behavior aggregate on traffic exiting gig E001, and we're saying we're going to basically override anything that was done on this edge router from traffic coming into the router before it goes into my core network. Now, obviously, we could modify a wide variety of values for my network, okay? All we're doing here is something simple. We're just setting all the INET precedence values back to the defaults. But it's a good example of how we can use a behavior aggregate. And you want to make sure that you understand how we apply this, because on your exam, you'll be tested by looking at a configuration and they'll ask you, hey, is this a behavior aggregate or is this a multi-field classifier? The behavior aggregate is applied to the interface itself. Typically, the rewrite is applied to the traffic going into the core network from the edge router. Then you'll apply a BA classifier as it exits the network, as it exits the domain, so that traffic is sent out without any BA on it. Okay? And then remember, of course, the multi-field classifier is done with a firewall filter. Okay, next let's talk about traffic queuing, which is an important concept here. I'm in operational mode. We'll do a show class of service, and then let's take a look at the forwarding class here. We kind of already saw these different default classes. So we have some default queues and default forwarding classes. Devices that are running the OS are going to associate each forwarding class with a queue number. So the best effort class is going to be given the queue number 0. Expedited forwarding will be queue number 1. We've got 4 queues here, 0 through 3. By default, Junos is going to send certain network control traffic, for example, keep alives, OSPF messages, BGP messages, RIP version 2 messages. These will be sent as network control traffic. Okay, you can see this has a queue number of 3. All the other traffic is going to be by default sent to the queue associated with the best effort forwarding class, which we can see here and on my J-series router, Q0. If you want to send traffic, as we've already determined, to the expedited forwarding or queue number 1 or assured forwarding queue number 2, then we have to set up some classifier to send traffic to those queues. we could set up our own definitions of forwarding classes. So let's go into Edit, and we'll do a commit confirmed 15 minutes. And let's edit the class of service. We could set of our forwarding classes, we could say Q0, instead of being the default, we could say we're going to call this regular traffic. And let's say we're going to set the forwarding class of Q1, we'll call it medium traffic. And then we could say for Q number 2, we'll call this critical traffic. And then we can do a show. And we can see there's our queues. Q0 defined as regular traffic, Q1 defined as medium traffic, Q2 defined as critical traffic. Now I've only got 4 queues on this particular platform. So if I try to generate more forwarding classes for more queues than I have, I'm going to get an error message, right? Even if I try to do these in here and then I tried to commit this, it's not going to let me. Really, most of the platforms running Junos are going to have queues 0 through 3. Now, even though I named my queues regular traffic, medium traffic, and critical traffic, the Junos is still going to forward the traffic based on the corresponding queues. Also, the default BA classifiers and the rewrite rules will map traffic to and from queues 0, 1, 2, and 3. They don't care about the names that I've assigned to them. Now, why are forwarding classes important? Because our other class of service rules are going to actually reference the forwarding classes as opposed to the queue. And I mentioned on some higher platforms, there isn't a one-to-one relationship. Now, how do we control the way that our Juniper router services the queues? Well, we do this by configuring schedulers and scheduler maps. Let's talk more about that. Okay, my router is going to control the queues using schedulers and scheduler maps. So the scheduler is associated with a particular queue and forwarding class through the scheduler map. And we can control the order in which packets should be sent by defining a priority and a transmission rate. Okay? So these two things right here are going to define the order in which the packets are transmitted. And we do this for a forwarding class. My 2320 will typically transmit packets from forwarding classes or queues with a higher priority before those packets that have a lower priority. And you can configure a transmission rate for each forwarding class. The transmission rate is going to control how much bandwidth the traffic associated with a given forwarding class will be able to consume. And by default, the software assigns 95% of the bandwidth to the queue associated with the best effort forwarding class, which in my case is Q0, or what I renamed regular traffic, remember? So again, by default, 95% of the bandwidth is going to go to Q0, and 5% of the bandwidth is going to go to that network control forwarding class. And if I go back here and take a look, notice that that's Q3. I didn't change that one, okay? That's still in place. It's still the network control. I only renamed Q0, Q1, and Q2 is called critical traffic now. And if I want to, I can configure a transmission rate for each of my forwarding classes. But at this point, Q1 and Q2, or medium traffic and critical traffic, going back to my configuration, those two are getting, at this point in time, 0% of the traffic, or 0% of the bandwidth. And by default, all of the queues could exceed their assigned transmission rate if the other queues aren't fully utilizing their assigned rates. And by the way, we could actually configure our transmission rate with the exact option, and if we did that, it wouldn't be able to exceed its configured transmission rate. Now, in addition to the queues, we also have buffers, okay? And the buffers are going to operate pretty much the same way by default. The buffer size basically is you have 95% of the available buffer space will go to the best effort queue, Q0, and 5% of the available buffer space goes to the network control forwarding class, which in our case, in most cases, is Q3. All the other queues have 0% of the available buffer space. So if you use queues other than the best effort and network control forwarding classes, then you need to assign buffers to those queues. So as the buffer fills, it's more likely that the red algorithm will actually drop packets. And you can actually designate an exact red drop profile for each queue. But the default configuration action is to not drop packets until the queue is full, and only drop packets then. You definitely want to check your documentation for your particular platform. But you can see that these are the 4 scheduling components: the priority, the transmission rate, the buffer size, which is pretty much operating the same way as the queues are, and then the red configuration, which, as I mentioned, is going to drop packets if the buffers fill up. Now, there's also something that's called queue priority. And Junos will support several levels of transmission priority. And let me clear this out here so I can write this down. So we have 4 queue priorities: high, medium, low, and low. And having this priority structure will let the Junos service the higher priority queues before the lower priority queues. And this scheduling will determine the order in which output interfaces transmit traffic from the queues. Therefore, the queues that contain the most important traffic will get better access to the outgoing interface. So the software has to actually explore and examine the priority of the queue. Also, the software will determine if the individual queue is within the defined bandwidth profile. Obviously, higher priority queues, like high, are going to transmit packets ahead of lower priority queues. So the final thing we want to do here on this scheduling topic is you want to go ahead and define our schedulers and scheduler maps and show you how that works. Let's go back over to the 2320. Now, before I can take advantage of this scheduling and this queue priority, I'll have to apply a scheduler map to my interfaces, either a single interface or multiple interfaces. And I'm going to go ahead and use the default classes that are in your Junos for the sake of the exam. Okay, so, and I need to edit the class of service, and we're going to edit the scheduler map area. So I basically have to set my schedulers. So we're going to say, let's set, and we'll call this my SMAP, my scheduler map, and we'll say forwarding class, start with Q0, okay, best effort, and let's just take a look at the options here. Okay, these are the 4 we talked about. Okay, so we're going to set the forwarding class first for best effort, and we're going to say the scheduler, we'll call this schedule BE. Then let's go up and do the same thing on my SMAP, but this time we'll say forwarding class expedited forwarding. We'll make this schedule EF. Got to go back up and put the scheduler keyword in there. Say scheduler EF. Okay, good, like that one. Let's go back up now and say for the forwarding class of assured forwarding, the scheduler, we'll call this schedule AF. And then finally, for the forwarding class network control, the scheduler is going to be called SCHED NC. We can do a show command. Here we can see my SMAP, my scheduler map, and this is what we're going to be using, by the way, to apply to our interfaces. So we could say my SMAP has the forwarding class best effort with a scheduler referred to as schedule BE, schedule EF, schedule AF, schedule NC. So we want to go to the top and get into the edit class of service interfaces area. And so to do it on an individual interface by individual interface basis. So for example, if I want to do it on that outside interface, I could say set gig E003. I could say and this is to turn on those features, the scheduler map I want to use would be my SMAP. I could also do this. If I wanted to assign it to all of my gigabit interfaces, which might not be a bad thing, I could say set gig E dash and then use a wildcard to say I want to apply the scheduler map to all of my gigabit interfaces, or if I'm going to do all of my fast Ethernet interfaces. right? I could say, let's do scheduler map, and let's apply my S map to all of those. So now my scheduler is going to apply to all the traffic across my gig E03 interface, or if I did all my gigabit interfaces or all my fast interfaces, it would apply to all of those interfaces. And again, like I said, we can go much deeper than this, and we can actually get granular with modifying the transmission rates and the buffer sizes on a scheduler EF, scheduler AF, scheduler NC on an individual basis. Let's say we want to do this. Let's say we want to edit class of service schedulers. Okay? I could go and I could set for scheduler best effort. Okay? Notice it's up here, Sched BE. We know that Sched BE is getting 95% right now, but I could go and I could set for Sched BE, I could say the transmit rate is going to be a percentage of, instead of getting 95%, let's say you're only going to get 60%, right? So the point is, I can change these schedulers, and since I've applied the schedule maps to all of these different interfaces, globally, let's say all of my gigabit interfaces, I'm now really modifying the best effort scheduler and only allowing it to have 60% of the transmission rate and 60% of the buffer size. That also leaves me the capability now, since I'm using 60% here, and we know that 5% is being used by default for Sched NC, or network control, I could give more to network control, or I could assign more than 0% to EF and AF. Okay? And again, all I would have to do is use the methods I've learned before of traffic classification, right? Using a multi-field classifier or using a behavior aggregate marking or classifier. I know that I can modify and apply this to ingress or egress traffic, right? I can use the firewall filters in the multi-field classifier, or I can use the BA marking to say that certain traffic is going to be using the forwarding class best effort, or the forwarding class expedited, or forwarding class assured, or whatever else I've named these, right? I know that I've named this one something different. These have already been renamed, so I would use those user-friendly names, and I can use my class of service processing to assign these schedulers with their different percentages to different types of traffic, right? That's how we tie all this together. Okay, again, I went a little bit off the reservation, a little bit deeper, but you can do some research on your own with this at Juniper. There's several white papers and there's good information up there. For the exam, though, I think you're pretty much ready to handle anything you're going to get regarding class of service on your exam. In this CBT Nugget on class of service, we covered policing or rate limiting, talked about the definition of class of service and the components, the different deployment methods, and then several examples of class of service in action. I hope this CBT Nugget has been informative for you. I want to thank you for viewing.